So for today, if I had you graph this, I looked at a lot of papers and I saw people kind of go like this. And that's kind of the right idea. But it has to go through two key points. Those two key points are 1, 1 and -1, -1. It has to go through those. You can't just, the other ones are just a sketch. This is an actual graph. I got the idea from the little sketch, but this is a graph, and the graph has to have those two key points. Next, this asymptote that runs along the x-axis, is that called horizontal or vertical? Horizontal, because it's like the horizon. And its equation, you can't just say x-axis. You have to say the equation. Right underneath it, right here, write the equation for it if you know it. If you don't know that equation, there goes another point. All right, the x-axis is y equals 0. Got to remember, there's a lot of counterintuitive in math. It seems like it would be x equals 0. It's not. It's y equals 0. Because every point on that line has y equal to 0. There's a lot of different x numbers on that line, but every y is 0. And then, of course, the asymptote that goes this way is the other way around. It's not horizontal, it's vertical. And its equation is not y equals 0, it's x equals 0. Okay, cool. Now, I want to remind you, this was the hardest domain to write and the hardest range to write. And I'm going to get you started. The domain goes from -infinity to infinity, but there's something along the way that it can't be. Do you remember how to write that? As you are going from -infinity to infinity, the x values, domain is about the x, range is about the y's. As you're going across the x values from left to right, there's one thing it can't be, and it can't be 0. So you put a parenthesis around that, and then it starts again at 0, but it parentheses around that because you can't be that. And what goes exactly in the middle of that whole thing? Union, U. I'm going to make it white to stand out better. There we go. And the other one is exactly the same because it also goes from -infinity to infinity with a stop at 0 along the way. You can't touch 0, so I'm just going to write same. All right, any questions? That was all really important review. Now, if I said this was my function, and then today I said, but I want you to do this to the function. I want you to take the function and subtract 3 in there and plus 2 out there. And when we're getting extra tricky, we'll say like plus 5 out there. But that's just an add number, just like the plus 2. If you ever see something out in front like that, that's just adding, just put it at the end. You just have to know that that's the same thing. You move it to the end. And then I hope you remember that I told you that would be 3 down or up or left or right. Which would that be? 3 to the, say it if you know it. Right. 3 to the right. If you thought left, I get it. That is the intuitive answer. But when you're inside here, you can't trust this stuff. It's not left, it's right 3. Right 3. And then that 2, is that up or down? Up. Because it's not inside, we can trust it. And then the last little thingy, there were so many things you learned this last week, was that there was horizontal on the inside, and what do you think on the outside? Vertical on the outside. High, low. Horizontal inside, vertical outside. Okay. Whew. So if I took this whole function, I moved it 3 to the right and up 2. If I actually made you do that, do you get that the asymptotes would move with it? Everything would move with it. Now, if I had that kind of cool thing that you do where you can lasso something and drag it, the only problem is it would probably drag your x and y axis with it if you lassoed this whole thing. But I think I've seen some kids that are like a surgeon on this. They take a little lasso and you can grab this part with your little lasso and you could drag it and then grab this part here and drag it and then grab the dotted line for the asymptote and drag them. And do you get, you drag everything, right, 3, and up 2. Okay. So let's give you a much simpler one. Let's see if you remember this one. This is the square root graph. And you'll be able to tell that I moved it from where it normally lives. Do you remember that one? But it doesn't start there usually. Usually it starts at 0, 0. So agreed that I moved it? Then tell me what its equation is. It's not just square root x. That would be if it was at its normal home. What's the equation for this one? When was this person left for good? Have they been there for a while? Okay, well, all right. So, if anybody doesn't like their current seat and would like to take this seat, apparently it's open. You want to take that seat? Sure. All right, you're in. You got that one. Roasting by the window? Too much sunlight? Mm-hmm. Was it too much sunlight? Whatever. You're closer up is better?
Yeah, I'll just try this one for today and see.
Okay. All right. And now there's a spot open by the window. If anybody really wants to move over by the window, I'd be open to having you move over. Just gotta say something. All right. Okay, here we go. So you should have said that thing moved 3 to the right. So inside here, I'm gonna put a plus or a minus 3? Minus 3. That should be a conflict in your head because it kind of moved where the positive numbers are, and yet I'm saying minus 3. Yeah, you don't trust stuff on the inside. And then it moved up 2, plus 2 on the outside. Raise your hand if you had that one right. Okay, cool. All right. Next. What's its domain? What's its range? Remember that this does not have an arrow on both ends. It does not go forever in both directions. It goes forever in one direction. Domain is from left to right. Many of the domains are from negative infinity to infinity, and this is not one of those. All right. Domain is from left to right. How far to the left does it go? It does not go to negative infinity. It stops right there. It doesn't go any further than that. So that is at 3. Does it touch the 3? Yes, so there's a bracket. If you've gotten confused by those, it's if it touches 3, which it does. All right, I'm going to erase this out because there's not a line there. I was just trying to show you that it stops at 3, and then it goes forever that way, 3 to infinity. And the range of this thing is not, it used to be from 0 to infinity, but now it's from 2 to infinity. And just that little mistake right there would have cost me this whole problem. If you see it, raise your hand. Nice. Now what is it? Bracket. Got to be really careful. Math rewards careful people. Touches 2. The lowest it goes is 2. You want to see that point written out? Sometimes that helps people. This is 3 comma 2, and the y value there is 2. That's why there's a 2 there. Okay. Good. Now, the circle. This circle has been moved from the normal spot. Oop, I need a y in there. And its radius is not 1. This is a more complicated circle. Where has it been moved? I want you to think of it this way. The normal circle started here and had a radius of 1, 1 like that. Okay? This guy is much bigger, doesn't have a radius of 1 anymore. What's the radius on this one? Not 16. 4. The radius is 4. And the center of this circle isn't at 0, 0 anymore because they moved it. And a ton of kids are going to get this wrong. They're going to say that this went to the right 3. Is that wrong, or do you think that's right? Do you agree that it's right 3? Some people are shaking their heads, some people are nodding. All right, and other people are going to say that this is down 3. Something's wrong in there. And I know some of you are like, that's exactly what I thought. Something's wrong. Yes? The squared is oh, I get what you're saying. Nope, no, it's not that. That's a good question. There is squareds on there, but you do not have to square the 3's that's been moved. And it has been moved 3. It's just I did something wrong. Who can name the thing that's wrong? Yes. Why is it up, not down? I thought the ones with the Y values you just trusted. There's parentheses. It's on the inside now. You can't trust it if it's on the inside. So it seems like it should be down 3, but it's up 3. So many rules. Circles are different. Okay. So if I actually had to graph this, I'd move right 3, and then I would move up 3, and the dot would be right there, and the radius would be 4, so it would go to like here, and 1, 2, 3, 4 in that direction, and 1, 2, 3, 4 in that direction. If I can just kind of connect these, there's my circle. All right, this is like a review for the test, and the test isn't for like a week, so don't be all stressed if you're saying, oh, this is so hard. Yeah, I'm covering. And it's all review except with some like way harder problems. Like we told you about circles. Didn't show you any really complicated circles. All right. So, I'm looking at my notes here. Yes. What if I just said, here's the circle. What's its equation? Dot right there, and then it goes around a nice small little circle right there. What's the equation for that circle? Hint, it's not x squared plus y squared equals r squared. It's got to have stuff in there because you moved it and you know the radius. I want to make sure you don't think it's got like it's showing you extra little boxes there. Now you can see. It's just been moved 4 to the right and up 1. In a moment, I'm going to ask you to share this equation with the kid sitting next to you. Double check it to make sure that you think it's making sense. All right, please talk to the kid next to you. If I put 1 squared or just 1, it's the same thing, because 1 squared is 1. All right. So that one moved 4 to the right, and, oh, I got to double check myself. It feels like the equation I wrote is going to go down 1, but it actually goes up 1, because it's on the inside, and there we go. How many of you would have had that one right on the test? Okay, cool. Now, what's its domain and range? How far to the left, how far to the right, how far down, how far up? Here's a way to think of it. It's like, how far does it go this way? It goes from 3 to 5. And it touches both of them. It goes from 3 to 5. And then this way, I'll use white, it goes from 0 to 2. I need to know how many of you had it right. It shows me you know domain or range. Okay, good. All right. Surprising number of kids didn't know how to find some points on this. I think right now you'd be able to tell me it went right 5 and up 5. I think you'd be fine on that. But my question is, if I asked you to actually graph it, if I asked you to actually graph it, say that 3 times fast, can you find 3 points on it? This is such a critical thing. It's on the silver 20. Find points on. And I know for some of you, you've mastered it. And I know for some of you, you took it 3 times, and it's gone up every time, which is awesome. That's all I ask, is that you get better each time. And then we took it as a group, and a ton of you did not take a screenshot and Dropbox it. I'm not going to penalize you for that yet, but if you did it and you forgot to take a screenshot and Dropbox your results, you're not getting any points for it right now. I haven't slapped zeros in there, but please, if you forgot to Dropbox that, go Dropbox that. Okay, so what are some points? Well, you could just try putting in 0, but then you're going to be doing square root of -5. That's not going to work. So then you throw that out and go, I'm not doing 0. And I can't do 1, and I can't do 2, because they're all coming out to negative numbers. What's the first number that would work? Say it. 9 would work, but it's not the first number that would work. It would work. I'm going to put it on here. It's a good choice. There's a smaller number than that.
6.
6 would work, and there's even a smaller number than that would work. 5 would work. Those are the 3 you should try. Everybody stick in 6 and 5 and 9. All right, find out what your partner, the kid next to you, had for those 3 points. This is super critical. Five, 5, 6, 6, and 9, comma what? 7. 5, 5, 6, 6, 9, 7. We good? You understand that? Okay, awesome. Now, what's its domain and range? Hint, take 2 seconds, sketch it, and then the domain and range will be so much easier. Trying to do the domain and range off just the equation is really hard. But just sketch it. You know kind of what this used to look like. It used to look like a square root like this, but then it got moved. If you sketch where it moved to, then your domain will be easy and your range will be easy. See, once I move it up there, and I moved it 5 to the right and 5 up, that white one, now I just have to do the domain and range off of that, which will be so much easier. So whenever we ask you for domain and range, take a second, make a sketch, because now it won't be that hard at all. The domain is how far left and right it goes. It goes from 5 to infinity, and it touches 5. And never touch infinity, of course. Range, the lowest it goes is 5, and it goes up to infinity again, and it touches 5. So there you go. 5 infinity, 5 infinity. Make sense? All right. So the last melon, the last difficult thing. Would you please draw another XY axis, and we're going to make a little function that you've never seen before. This is not one of the 7 I taught you. I taught you this one. Don't draw this, just listen and think. What's that one again? Y equals what? That's y equals x. Good. And then I taught you this one. Y equals what? X squared. They're pretty much always x something, right? And then there's this one. What's that one? X to the third, or x cubed. Either way works. Good. And then there was that funky one we just did a second ago where it goes like this and this. This is just a sketch. It's not a graph. And it has asymptotes too. What's that one? 1 over x. Okay, good. And then we did this circle 2 seconds ago. That was x squared plus 9, y squared equals r squared. But now they give you a function you've never seen before and then say to move it. So it's going to start at 0, 0. It's going to go up to 4, 2. And it's going to go all the way down to 4, negative 2. There's a function. It's a function. You just don't know its name. It has a domain. Farthest left and farthest right it goes. It has a range. Lowest it goes, highest it goes. Okay. But that's not the question. The question is, if I tell you this is f of x, that's his name, is f of x. What would f of x minus 3 plus 2 look like? They're related. They're going to look similar. I know that in families, sometimes the brothers and sisters look ridiculously alike. And other times they just look a little bit alike. In this case, you just take this exact picture and you'd move it. What does this mean? 3 to the right and up 2. Okay. So to do that, I would take these key points, there, there, and there, and I would move those points 3 to the right and up 2. I'm going to make my new points white. 3 to the right and up 2 means this. The one that was at 0, 0 is now going to be there. 3 to the right and up 2. Here, I'm going to move the f of x here. It's kind of in my way. And I would take this, the top point, I guess you'd say, and move it 3 to the right and up 2. I didn't move 3 to the right, did I? Thank you. Good catch. I went 2 to the right. I guess supposed to go 3 to the right and up 2. Yeah, it's going to be right on the line, so I'm going to put it in red. And then maybe they make this red. And then this last point here, I'm going to move it 3 to the right and up 2. It's going to be right on a line. There. And now, if I connect my dots, let's not use white though, Mr. Server. That'll look exactly like the other one. Let's use green. There, the whole graph just got moved 3 to the right and up 2. Make sure I moved all the dots 3 to the right and up 2. Cool. All right. Now, we should practice this because today is the hardest day of math you've had so far, but a lot of it was review. And a lot of these are like test questions. I seriously would bet that there's a test question, like 5 of the ones I just did with you. 5 of those are test questions eventually. Okay, except with different numbers and, All right, so remember, not an assignment, but here's the ones that I think you should do in class, and I think you'll finish before you walk out of here today. We are going to skip these on the worksheet, so please write down skip. And again, you're not even turning this in. I just want to save you pain and suffering, and I don't want it to be too big. And I think you can finish this in class if I skip a bunch of them. So we should skip problems 1 and 2 and 6, 8, 10, and 12. And then I think it's doable in class. So that would mean we'd start with number 3. Everybody, please find the worksheet. Start with number 3. Turn that in. Get your iPad up. Can you find number 3 for me?
Just gonna sit it there.
Yep, that's fine. All right. Y goes up with x, and then y goes up with x plus 6. Plus 6 on the inside. I think it says that for part A. Then what am I supposed to do? What's the whole point? Tell what? Describe how, just read. Translates the graph of. Okay, so translates is like moves. So how does this move the graph? Don't overthink this, it's super easy. Right 6. Nope. Even I just did it. It feels like it should be to the right 6, but it's on the inside, so it's left 6. So easy to make that mistake. There we go. Olivia, part B. Yes, you, Olivia. Just read me the problem. Oh, f of x plus 4? Okay, no problem. F of x plus 4. Minus 2. Awesome. That just moves 2 directions. Olivia, can you do it?
Yeah, so left 4.
Correct.
And down 2.
You got it. I think you got the idea on those. You'd probably be able to handle 3C yourself. Let's go to number 4. Number 4 has these pictures. And then they ask you to like do something to it. So they got this little lightning bolty thing. Let me see the question. And then it says gravity to write an expression, function notation for the transformation shown in A and B. Oh, okay. So the original one they give you is a lightning bolt that kind of looks like this. Do, do, do. And then part A over here, they've moved the lightning bolt. And what you say is like, they did this. They moved it 1 to the right and up 1. I'm not saying that's the right answer. I'm saying you give an answer like this, where you say that's where they moved it, but you say it in function notation, like the blue writing there. Okay? All right. So this is the part where you have a bunch of time to work. And I strongly recommend that you work on this until you finish it. And if you get stuck, which you probably will, you should ask the kid next to you or walk up and get some help. And that's all I got for you for today.